Okay, so yes. Yes, Xenophon, would you like something to say?
No, sorry.
Okay.
I'm okay. Sorry.
Okay, great.
Leave my questions, George. I had the question from Mick, and I had another question that came up to me right now from Mick. But leave those two for the end. Start with the other ones, and then we'll see how it goes. All right? Are you gonna do the reading?
Whatever, if you would like to do that.
No, please do, by all means.
Okay, thank you very much. Okay, we have a question regarding PICV valves, whether they are sensitive to dirty waters. With water was that they have, that they need problem with cleaning. You have to clean the water. We have to make things for the water to be clean, to make sure that they are clean.
It's the same with another type of valves. If you have a standard valves and have a problem with dirty water, and also PSV, you have the same problem.
Okay.
And also the new technology, some new valves about PSV, you have the opportunity to replace the garbage, or to clean.
Okay. Okay, great. And how about high differential pressures? What are they sensitive on high differential pressures? If we have a situation that we might have a high differential pressure that, as I see here, above 5 or 6 bars, if the valves are sensitive on that.
The design of pressure independent control valves, it's to work with high differential pressure. I think the normal, it's about it's easy to work with 6 bar differential pressure without problem.
Okay, and are they also available without the temperature sensors?
Yes, in the market has another companies has electronic valves without pressure sensors, only with a flow sensor.
Okay. Sorry, I'm just trying to read another question. Sorry about that. So
George,
there is
all the questions, it's about the valves?
No. It's just the first ones. That's about that. So I'm having, if we can have some extra info about potential buffer uses, acting as system performance change absorbers, and performance safety too, in cases like fast bypass valve speed or fast load changes. I think, Mick, probably that question goes to you, I presume, because it has to do with what you said about the response of the system.
Sure. Let me address two different things. First, what I spoke about were the isolation valves for the chillers, and it would be best if they were linear valves. That is, if they're 50% open, you get 50% of the flow rate. Usually that's not a butterfly valve, but I will say many times we do see butterfly valves installed as isolation valves. We just need to be much more careful, because if you open a butterfly valve 20%, you might get 80% of the flow rate. So now with respect to the valve in the bypass line, we didn't talk about that today, just from a timing standpoint. That valve is very important. A pressure independent valve is not required there, but I have had a number of design engineers say that they specify pressure independent valves in those positions. And the reason is, first, the valve needs to be closed when the system's at its highest pressure at design conditions. So the actuator has to have enough torque to close that valve. Secondly, that valve is only going to open when the system flow rate's gone down and we're at a much lower pressure. And we need to be able to get the full valve flow rate even at that lower pressure. So selecting of that valve is very important, the valve in the bypass line.
Okay, but also there is a question about using buffers as well. to
Using
act buffers, not butterflies valve. Probably.
buffer tanks?
Yes, exactly.
Oh, okay.
Storage tank. Storage tank.
Storage tank. Okay.
Yes.
So,
Sorry, yeah.
yeah, okay. If the bypass line and valve are right in the plant, that can end up being a short loop. And for example, let's say a butterfly valve is put for that bypass valve. It opens very quickly. We'll get a big slug of cold water coming back, and the return water temperature to the chiller will change very quickly, and the chiller controller may not operate very well. So many times, yes, a buffer tank is installed in the return side of the system to allow more water volume and allow the stable control of the chilled water leaving temperature.
Okay, great. We have also another question. It's also regarding the water quality. And the question is if you have looked at the performance of hydronic system from the point of view of water quality and reducing corrosion in systems. Can just simply improving water quality leads to significant energy savings? I think, yes, that addressed to you as well, Mike.
Yes, thank you. I don't have any data on that, but we all know that fouling of tubes, particularly in high performance chillers, the new heat transfer tubes give great heat transfer, but when the tubes get fouled, there's a resistance to that heat transfer, and that is seen in a decrease of the refrigerant pressure in the evaporator or an increase in the condenser. Either of those leads to more compressor power. So what we see some people do in order to try to keep the system operating efficiently is they actually trend the approach temperature in the evaporator. That's the difference between the water temperature and the refrigerant temperature. And the same thing in the leaving water temperature and the refrigerant temperature in the condenser, and they use their building automation system. And as long as those stay consistent, we probably haven't had any fouling of the tubes. But when they start to deviate, that's going to be a direct signal that tells us we should probably look at maintaining that system and cleaning those tubes.
Okay, great. Alkis, would you like to pose your question?
Yes, please. So here comes the first one. I know it's a probably tricky one, but I'll do it anyway. And it goes to Mick, of course. So you said that we should increase the delta T in coils up to the maximum of 10 degrees Celsius in order to adjust the flow rate and have apparently significantly low consumptions in pumps, which is expensive to the cube. And the coil will give us almost the same capacity in kilowatts probably or whatever.
Yep.
But what happens to the dehumidification capacity of the cooling coil? Will that remain the same?
The answer to that is yes. I tried to explain that on the slide where I was talking about the airflow and the wet bulb temperature, but I will work on explaining it better in the future. Both, we can select the coil and find out what is the chilled water temperature needed to give us the same leaving air conditions. And then the sensible and the latent loads will be the same for that coil. So if the leaving air conditions are the same, the loads are the same.
Exactly. Thank you about that. I kind of see that, but it wasn't clear. That's why I'm kind of clarifying that, because those of us who, I know. Those of us who do follow 90.1, we kind of know that already. So the other one is the sensitive case of piping. So let's say that we have a project, a lead project, even better, and it's me, it's George Pandelis, and Kostas Ballaras, the three of us involved from different perspectives. One of them is going to be the designer, the commissioner, and probably the customer's view. And I'm going to be saying that, look, guys, I've been teaching in the ASHRAE Learning Institute for the HVAC design, all those engineers, that the ASHRAE says it is okay to oversize piping and ducting, and it makes it better for any kind of criteria. It is not okay to oversize. It's probably better to undersize chillers and boilers and things like that. And this is going to be my point of view. And then probably George will say, well, we have to see the cost benefit, and maybe not too large and not decrease the pressure drop, because this may have significantly higher expenses. And then some of Costas Balazs will say, well, the high performance building design would say you to do so. So which one is correct? Which one would you do?
I think the first thing we have to do is talk to the client. What is their goal on the project? And if the goal is to save energy or reduce emissions, we're going to have wider latitude with the design decisions that we make. And we're going to explore, I'll say, that larger envelope that I think George talked about with respect to the decisions we make. If the only goal is to reduce the first cost, we're not going to oversize the pipes. We're not going to oversize anything. But we need to make sure that we communicate what we've heard from the building owner and then why we're making those decisions for the specific application. As engineers, I think we can often balance those first costs and those operating costs using the higher delta T's, lower flow rates, using variable primary flow in order to provide solutions that you can save installed costs and operating costs.
And if also I may add, this is, sorry, Alkes, you are muted.
Sorry about that. So
Okay.
Before you say that, Costas already replied that he's always right, which makes sense. And yeah, I know. And in the idea of high performance building designs, that's not the way to go, Mick. I mean, I understand the client's perspective, but the decarbonization phase we're going through doesn't follow those steps, and it should follow those steps.
I fully agree, but there are times when, okay, we then have a choice. If that's something that we want to do and the client says that's something they don't want to do, maybe that's not a client that we don't want to perform work for. So we as engineers, we're going to provide the best options we have for our clients. And then there's sometimes there may be some times when we decide that those aren't the clients that I feel that our firm wants to work with. So Costas is always right. And what I've found is that many engineers are always right. And there are a lot of different ways to get to a very good project. And sometimes getting to the perfect project gets in the way of getting to an excellent project. So I will not go on record as saying Costas is wrong, or Alkes, or George, or anybody here.
No, but I just added Costas as a panelist, so if you can hear us now, I think he can interrupt and say if he has something else to say. But in the meanwhile, I think I have to stress out as well that, as we said, and as Mick also mentioned very well, that this is something that engineers should examine and stretch and find out. This is something that we have to elaborate and put all these things in the balance and see what we can do. But also, ASHRAE is helping us with that, because there are already tables that they can help you choose the correct pipes on the life cycle, from the life cycle perspective. So not selecting them from maximum speed, from maximum velocity, from minimum delta P, but which will be the beneficial for you from the life cycle perspective, and taking into account how many hours your building is operating, which I think is very very interesting. And can I also have a question as well? You mentioned some things about also about how you're going to do the balancing and the balancing valves, and but also you mentioned as well that we are with all the arrangement that we can take control, read the control of the control valves, with the position of the control valves, we can have them the dead band between 75 and 85%. And also, I remember, because you have mentioned also Steve Taylor, I remember he had an article about that and saying that, okay, not only we don't need balancing valve, but probably it's not good to use them anyway. So I would like to hear your opinion about that, because, okay, please.
Sure. And thank you for bringing that up, because what I'm expressing are my opinions. They are not ASHRAE stances. They are not from the ASHRAE board of directors. They're not even from my company. These are just my experiences. I get to go to a lot of chilled water systems when we can travel, and I talk with a lot of design engineers, operators, and technicians that work on the systems. I will say that we are seeing a significant number of systems where they are not installing balancing valves, but rather they are using the pump speed in order to balance the system. Now, I think Steve Taylor's paper talks about his opinion. The way I read it is he doesn't think balancing valves are correct. And he and Mark Hegberg have been on opposite sides on ASHRAE panels about this. And neither one of them is going to change.
Okay.
So, but I will say from a practical standpoint, I'm seeing fewer and fewer people use balancing valves and instead use pump speed to balance the system. There are going to be some times when there are drastically different pressure drops. Say we're a campus system and there's a building right next to us and another building 2 miles away. We probably have to do something in the building that's close in order to make sure we aren't overpressurizing the control valves at the air handlers. And that could be a balancing valve.
Okay, great. Thank you very much.
I'd be interested in George's opinion on the presenter from on the valves. He knows more about valves than I do.
George,
Right.
your turn.
No. You are muted, George.
Okay, now I hear
Okay.
you. Okay, and the opinion of Siemens is to use a pressure-independent control valve. But yes, in the past you have some articles on some topics with to make balancing with the pumps. I think I'm not specialist in the pumps because Xenophonics is the specialist of the pumps. But I think it is not so easy to make flow control with the pumps. With one reason, you need for every terminal, for every fan coil, for every pipes. Pumps. So I don't know, maybe before a few years, Vilo presents small pumps with intercrate control. I don't know if it is happy or not with this kind of control. But I think the future will be changed to go to more intelligent, to more Internet of Things valves, to more special functions. Don't forget the pressure-dependent control valves. It is not new. It's 20 years in the market. And you need 20 years from mechanical valves to go to electronic valves. So I don't know which will be the future after 10 years, because everything changed very quickly.
So I think what we are imposing right here, George, is that we need to ask also Xenophon opinion as well on that.
I will say that in any way, how the things emerge with the PICV valves and other systems controlling, always the pumps will have to have speed control, because in any ways the flow will be reduced. The delta P also will be reduced to the delivery and return system to the consumers, let's say the fan coils. So in every case, either there will be a built-in, let's say, brain of the pump controlling, self-controlling the pump to the variable system conditions, or the central control of the BMS system will give an instruction to the pump to reduce the speed or do something else. So in any ways, the future is towards connectivity, more things connected, smartly connected, and variable control will still, I think, keep existing to support these emerging smart systems. That's my opinion in terms of, on behalf of Vilo pumps.
I'm
I
gonna ask
agree
something.
with.
Sorry about that, George. Before I lose it, because I'm getting old and I keep forgetting things. So there was a question in the panel, and I think they haven't replied that, and it connects both of you. It says that if there is a way of connecting a PICV valve, a smart valve, intelligent valve, whatever, with the pump directly, not via flows, pressures, and everything. If there is a way, or if there will be some ways eventually, because the IoT, the Internet of Things, would assume sooner or later that you two guys and all of you should start communicating and, you know, working together. Have you got any solution to that, or any kind of research on that, or what, any thoughts on that?
Not until now direct, but with the use of BMS, of additional controller, yes, maybe will be. But I say again, the market changed very quickly. I don't know what happened after 5 years in this kind of products. But also, I agree with Mick. The basic of all, it's the brain, it's the controller. Sometimes it's a controller from with electronics, sometimes it's controller from human. But without control, it is not possible to work. It is not possible maybe to have the best valve, the best pump, the best coil, the best chiller. Nothing control with the human, the engineer, to make the puzzle. I agree with Mick in this for this type.
Right, puzzle solvers then.
Mm-hmm.
And also, this is our job, the mechanical.
I think this is how we explain to Ben and everybody's children. I think this is what we do. We solve puzzles.
He's 34 now. He's really smart.
Okay. So I don't think Alkis helped me on that. You are getting old, but I'm getting older. I don't think
questions. Out of 230 that were here, I still see almost 100 being here. So thank you all for being with us, being patient enough, listening to us, and listening to all these wise guys, Mick, George, and Xenophon, and George, of course, a little bit. And George, you want to close?
Yeah, okay. Thank you very much, everybody, for being here. Thank you very much for staying up to the last minute. Thanks all the presenters. Thank you, George. Thank you, Xenophon. And most of all, thank you, Mick, for being here with us. And closing, we would like to transfer all our warmest wishes from our chapter here and from our region, I think, that you may have a successful society here as a society president, and always feel that you are mostly welcome here in Greece, and you are mostly welcome not only the next year, but also the years to come, that you are mostly welcome to come and visit us in any other case. So thank you again. Thank you all again, and have a nice night.